Let's see where we're at. So last time we did binary search, a bunch of binary search stuff. We're honestly pretty close to finishing. We only have one more.
Like
I'm down to
unfinished.
do. Huh?
We haven't done that one.
I'm down to do the search and rotated array too, and then we revise.
Okay.
And then next time we will start the new topic. Oh wait, you haven't done a couple A.
Which?
Like you haven't done like cocos, bananas and shit.
Yeah, I've not done that.
Why?
It'll take up the whole day.
Mate, this one looks like it's gonna take a whole day.
No, it's not. There's an integer array, nums, sorted in non-decreasing order. Before passing to function nums, so rotated an unknown pivot index k, such that the resulting array is nums k. Let's just look at the example. 2, 5, 6. Okay, so it's sorted 0, 0, 1, 2, 2, 5, 6. Target is 0. Given the array nums after the rotation and integer target, return true if target is in nums. What does that mean?
Given the array nums after rotation and integer target, return true if target is in nums or false if it is not in nums. You must decrease the overall operation steps as much as possible. Okay, so we have an array, right? Like this is regular array sorted in non-decreasing order, and before it's passed to a function, it's rotated at a certain index. So we know how to perform the rotations, but I don't think we actually need. Well, actually, we can. What if we unrotate it?
Wait, I don't even get
We
what
can-
it is. How's it non-decreasing order?
No, so array, so nums to begin with is non-decreasing order, right? So there's an integer array nums which is sorted in non-decreasing order at the
Is that an
start.
example?
So there, so like that, right? So that's non-decreasing order. So that's in increasing order right there. And then before being passed to your function, it's rotated at a certain index. So we know, like in this example here, this is the original array, right? And then it gets rotated at pivot index 5. So it's 0, 0, 1, 2, 3, 4, 5. So it grabs all of this and it rotates it. So this will be at the start now, and there's whatever's remaining, which is that. And then now we need to just perform binary search or something like that to check if target is in this array here. But you can't perform binary search on an array where you know it's not sorted, because this is no longer sorted. So what I'm thinking of immediately is there a way that we can unrotate it? So can we somehow reverse this operation so that this goes back to the front again? I guess one way we could do is we could do a for loop, right? We keep iterating through it until we encounter like 0, because 0 is less than 7. And then since we do that, yeah, and then once we do that, we'll know the pivot index, so we can reverse it, or we can revert the rotation using the pivot index. The thing is that could be quite inefficient, because what if, like, I don't know, their input size is like 1 million, and then the pivot index is like 999,000. We'd have to like keep looking through all the way until we find a pivot index. That's the only way really I can think of doing it. One way also would be we can iterate through it, right, and just check if the number is equal to the target, and then to the point where we find that 7 is greater than the next value, we can perform binary search on the remainder.
So 2 binary searches. I think that's just less efficient.
I mean, you must decrease the overall operation steps as much as possible. So like what we're doing now, we are decreasing the operations.
So is it
I think the
easier to
first-
do 2 binary operations than
I
to
don't
swap it
think
around?
I don't know. I don't know if you can do 2 binary operations. I mean, you definitely can, but I feel like because you can iterate through it to find out the indexes, right? So we start here, keep going, and we see that 7 is greater than 0. So we perform binary search here using slicing. So we slice this section of the array, perform binary search,
I think
and
we check if the first half, if the target is less
in
than
it.
the end of the first half. If not, oh wait, no. If it's less than the first index, then we perform it on the end half. We don't actually do 2 operations.
So you're saying we just check here
For example, if
in the
target
first half.
is 5, we check if... Actually, how do we check that? Depending on the target, you select which half of the thingy to operate. So you only do 1 binary search.
No, it's not sorted though. Because look, let's say the target's 4, right? We want to find. Okay, let's just imagine like this 4 here doesn't exist. Let's say we want to find the target 4, right? We perform binary search here, and okay, let's assume this is like that as well. Look, let's say we want to find the target 4, right? We go middle here. We see 7 is greater than 4, so it's going to check this section here, and it's never going to see here.
No, you check the middle and the start. If target is like exists in there, within that range. If not, then do the second half. So it's 4 between 5, the pointer 5 and pointer 7. If it's not, then we'll do the second half.
Okay, so let's assume this is 3 then, right? And let's say the target's 4, right? You check, it's 3.
How'd 3 end up there?
Oh?
3 can't end up there because 4 is at the end of the array. That wouldn't have been rotated, would it? Because it's stored at the start.
Oh, but yeah, I think you're right. That's okay. Let's keep thinking. So this is the rotated array. So that means the value on the left has to be greater than the value on the right, like regardless. Greater than or equal to at least. I think that's pretty much confirmed, right? So I reckon what we can do is, okay, let's just say this, right? We have this example here, it's all in non-regressive order, and let's say we rotate it from here. Okay, we rotate it from here. So it'll be like this, and then 0, like 1, like that, right? That's the rotated array. Assuming that we rotate at this position right here. Yeah. So, and then we can confirm that all of the numbers on the left here are greater than all of the numbers on the right.
What?
So,
Yeah.
how can we like use that anyhow?
That what? The right numbers are greater than the... Wait, left are greater than the right. Yeah, we
Yeah.
check the lowest and highest of the first half, see if it's within the range, the target. That's how you select which one to do binary on. And that's only like a single like operation check. And now cut your whole process of doing 2 binary searches.
Okay, you start then. Can you, or like just give like write an example on your screen so I can watch you do it.
Well, that was basically it.
Oh no, I didn't understand what you were trying to put through there.
So like we have this and the target. They give us a target.
Yeah, I did.
Let's do here. Never mind.
So that's after rotation.
So this
That
is
one
after.
right there.
And so our target equals to 6. So here we already have pointer 1 at 4 and 7 after doing the rotating thingy. Pointer 2 is here. Firstly, since we already have the pointers here, we'll check if pointer 1 to pointer 7 is the target in between 4 and 7.
So what? So you got to start in the middle index?
No, because like we know that 6 is in between the ranges of 4 and 7, so that means it
Yeah,
definitely won't be.
but how are you getting 4 and 7 to begin with? Like what variables are
From
providing those indexes?
we got this, like you know how we found the pivoting index?
So what, we're iterating through it until we find the pivot index?
Yeah.
Okay.
And then after that, it's just normal binary search. But then if it's not the case and target was like 3, 3 is not between 4 and 7, therefore we change our pointers to after the pivoting index to 0 and the last
Into the end.
index. And then you perform binary. And now you can't
So
find it.
it definitely is like, it would definitely work. I'm just wondering if it's going to be the most efficient. I think we just try that though, because I think that would definitely work. So I guess first off we want to find a pivot index, right? So it is. It's not something -1, eh?
Yeah.
And then
Should do -2 and check the next one, next index. If nums I plus 1 is smaller than nums I, then that's our pivot index.
what?
Is this assuming that there will always be a random occurrence of pivot?
Yeah, the index of the pivot can always be like any value.
Num is guaranteed to be rotated at some pivot, okay.
So it could even be pivoted at like the very start. So it's essentially just the same.
Okay, so we found that pivot is at index.
If nums I plus 1 is less than nums I. What do you think it's 1?
What?
Wait. So we just want to find a fit, so we check 2 against 5, right? So if nums I is less than nums I plus 1, pretty sure. If nums I...
No. It's in increasing.
Yeah, so you check
So
if
first
nums I
number-
is less than nums I plus 1.
Yeah, that means it's just in order, is it not?
Yeah, and we keep going, and eventually we're going to reach a point where nums I is greater than...
So where are you going to put in the if statement?
Well, you keep iterating, right? And this is always going to be true, right? Because it's true.
Yeah.
And eventually it's going to break.
But there's no point having the if statement. Shouldn't you reverse it and then inside the if statement you actually replace the pivot?
nums I.
But then once we find the pivot, is the pivot going to be the same index? So example at pivot 1, 0, 1, 2,
And don't we want to store the
2, 3, 4, 5. Zero, 1, 2, 3, 4, 5. So it will be pivot minus 1. So we'll check first if target so if nums I is smaller than nums I plus 1 is smaller than this, pivot will be here. So this will be P2 basically. So target nums smaller than nums I. Target. Oh shit. Target is bigger than nums 0 and target is 1.
And we're going to provide the indexes. Wait.
What?
And we can do 8 left. But this is local. You have to update it. Right, it's going to equal to index else.
How do I do binary search here? If middle is bigger than target. And P2. Return true.
User is not authenticated. What does that mean?
Middle is smaller than target. What? I think I have to do some edge cases. I passed the normal one, but submission failed.
Wait, what the fuck am I doing?
Right, nums equals 1. So if nums equals 1, skip all this. How does middle equal 0? Shit.
Nigga, the fuck?
How's this fail? Not performing on 256. Target is 0.
I think it's with your line 17 to 20. So if target is less than nums and target is greater than nums pivot, show me checking less than or equal to. And then also, in a situation where,
So if it's checking target is 2, bigger than 2, no, less than.
also isn't it
No.
greater than equal to?
Where?
Oh. Well, then you need to reverse the
Target is bigger or equal to 0 and target is smaller and equal to nums pivot, which is 6. So it's not, so P1 equals pivot plus 1, it will go to 0. P2 is equal to this one, middle will be 0, or P1, if nums equals target, return true, so why isn't it return true? There's something wrong with here then. Does yours work?
wait, hold up. And then, because you need this right, so you need to check if the target. So if the target is greater than or equal to 2, right, then it's still valid, right? If it's greater than or equal to 2, and if the target is less than or equal to 6,
which is
then we know that it's in that range, right? No, I don't think that would work actually. Because what if like, okay, right? So we know 3. 3 is greater than or equal to 2, and 3 is also less than or equal to 6. So we're passing this index when it's actually in here. So you can't do this check, because even if it's sorted in non-decreasing order, it might not be in here.
no, 3 would not be in the end, because it would be after 2. It would always be after 2 in the first half.
I think you do need to reverse it. Like you need to find a pivot index and then unrotate it, and then perform binary search. I think you have to. But unless you check in here at the same time,
What, 2?
then so it is right. So you just check, right, if nums I is equal to target, then we know we can just instantly return true, right? Okay, but let's say 0 isn't equal to 2, right? So we just check. Okay, so is 2 greater than this? It's not. So we keep going. And we take next. Is 5 equal to 0? It's not, right? So then we check. Is 5 greater than 6? It's not. So continue. Now is 6 equal to 0? It's not. Now is 6 greater than this? Yes, it is. And now, since we know that, we know the pivot point, and then at that point we should just use this array instead, because it never returned early from here, so we should return this one. So what we can do is, we don't even need to perform this check here. We just do left is equal to pivot point, and the right is equal to dot length. Well, we actually never needed it. We just need to redo pivot point, and then perform binary search on them. While left is less than or equal to right. I think that's honestly going to work.
Zero P2. Wait. No.
Pivot index. Maybe we just do an edge case. Look, this is the input I failed.
No, I failed that one as well before. Isn't it pivot? If it goes to the right side, isn't it pivot index +1? Your left.
No, I think this is right. I just need to somehow verify this I+1 thing. Because it iterates through it once, right? The first loop. Obviously it doesn't equal the target, so it doesn't run this. And then it checks this and it instantly breaks. So I need to check, right? So, we just need to. So if I+1 is less than or equal to nums dot length, or it might be just less than. And then pivot index is equal to I. So I+1. Holy fuck. I'm ready to see what I'm doing wrong. I'm gonna use AI check. I feel like I'm close enough. There's a couple of edge cases we're missing. Major logic bugs in your code that break the algorithm. Breaks after the first iteration? Oh, it does. So you want to break here. Wrong search range.
Pivot +1. Gosh.
You have to do a modified binary search. We don't actually need to find a pivot point.
Give up. So what's the issue? What's the issue? So it searches from pivot 1 to the end.
The fuck? Should we watch a video? Should we watch a video?
Mine's accepted. Dude, add num's length minus 2 instead of 1.
So yours works?
What did they say the issue is with yours?
I don't know. Can I see your solution? Yeah, just start at the top. Int pivot 0 0. If num's I plus 1. If num's I plus 1 is less than. Why do you I plus 1 first? So you're checking if num's like 5 is less than num's I.
You can do it the other way, but bigger.
My way works. How do you take care of the edge case though?
Which edge case?
Like what if I plus 1? Like I plus 1, right? I plus 1 could be like.
Yeah, that's why I had it at 2, right? But then ask thingy, it said to change it to 1. And it still doesn't break. But apparently that was the issue with mine. I don't understand why.
If target is greater than or equal to num 0, and target is less than num's pivot. Let me just try your way. And you did another if statement. If target is greater than or equal to num 0, and target is less than or equal to num's pivot. I don't think you need that though. P1 is equal to pivot plus 1. Why would you pivot plus 1? Can you scroll down? So if it's greater than target, P right is equal to middle minus 1. I mean, I feel like implementations are identical. But I failed this test case where it's like this.
I don't get how it doesn't return true in this thingy for yours.
If num's I is equal to target. What?
-1, so it never runs. Oh. What the hell?
This performs binary search on both the 0.
So they want you to search on both or what?
This one here,
Oh,
you
keeping
find
your
a pivot
structure.
point. The fuck? So is it just that -1 shit? Let's just try removing it and see how it runs. Bam! Index out of bounds. Let me check. I plus 1 is less than nums.length.
Is it something to do with your pointers? What is that if I plus 1 is bigger than nums? Oh, wait. Oh. What do you do? What do you change?
I just had to check this.
Okay. So this is solutions.
And because it pauses but has a hidden flaw.
What is the solution?
I haven't checked every element because it breaks early until the pivot point. Basically irrelevant. Wrong. ChatGPT is fucking retarded.
Dude, these guys are writing more inefficient code than us. What's the optimal approach?
Pivot detection works at 4 is greater than 2, sure. And 1, 3, 1, 1, 1, target is 3. So we check is 1 equal to target? No, it's not, right? Then we check is I less than 3? Yes, it is. So we continue. So and now check is 3 equal to target? Yes, it is. So we instantly return true. Man, I don't know if ChatGPT is retarded or not, but I'm sure the test cases would like have duplicates like being tested. In 0 millisecond runtime beats 100%. Like, if it's 0 milliseconds, I feel like that's pretty fast. But to be fair, everyone's solutions are running in that runtime. So maybe the test cases aren't actually that big. Because all of the test cases aren't that big.
Probably.
What are all the solutions like?
They're all just doing everything inside the binary search loop. They don't do any of this checking if left or right.
Well, I feel like our solution definitely works. It's just like apparently it's not the most efficient because yeah, I mean to be fair, it isn't the most efficient because we're performing an operation at the start, so it can be all in at worst case scenario. But I think in the other iteration, it's like guaranteed O log n.
What's brute force? Iterating through the whole thing?
Yeah, iterating through the whole thing. So we're kind of brute forcing at the start, and then like our approach works, and it definitely is like efficient to a point, but it's not the most efficient. So I guess like if there is a follow-up question, they're gonna expect efficient approach, which is just a single binary search.
That's alright. Good attempt, good attempt. That's a good question.
Yeah, we actually like would solve 40% success rate.
Really? 40?
Yeah. But again, I guess our solution wasn't the most efficient. Interesting. It was a fun one at least. Alright, so I'm down to not do any more binary search. Like these hard ones, for example. I feel like we're not getting interviewed on those, bro. Let's just.
Yeah, we're fine on binary, 2 pointers, and most of arrays.
We have two options now. We can either continue and do some revision.
What I'm
Like,
thinking is we should. What other topics do you think would be asked in interviews for a graduate?
let's just still search.
Ask
Honestly, I feel like
because if we have no idea and like we have interviews next month, and they ask us on like heap questions, greedy tries, then or backtracking actually, then it's over.
backtracking.
Yeah, I saw easy backtracking questions in some, like permutations. Well,
90%
not
acceptance
exactly.
rate. Sure, I'm sure we could solve it. We need a plan. I mean, I feel like we're doing pretty good so far. Like we've covered the basis of everything. Like we're just gonna forget, bro. Like if we do like end. Sure, mid interview you might be able to like grasp on like an idea of how to do it again, but especially if it's like a medium question, like this FF. Even if we get a medium question on one of these ones, it's like 50-50 chance you get it. This is a shit. Um, Australia graduate software engineer interview question topics.
Top priority arrays hashing, 2 pointers, binary, stack, linked list, trees, very important for grads. Excuse me. Heap, then so we should definitely do some linked list. I don't want to do stack. I don't like stack. We should do sliding window.
We already got that sliding window.
Did we?
The fuck, I haven't like, it still contains duplicate. Let me see.
Sliding window.
Yeah. I think priority, honestly, is we just try and do all the topics. We try to do all of the questions first, and then we just. I mean, that's honestly no. What we're doing now is fine, man. Like we're just trying to speed run all of the topics, and we're revising as we go. That's as good as we get.
Yeah.
Alright, let's do sliding window.
Contains
50% acceptance rate for an easy.
You need to open up a sliding window algorithm, bro. Given an integer array nums and integer k, return true if there are two distinct indices I and j in an array, such that nums I equals j. So k equals 3, there's 3, how's that true? Two distinct indices. Bro, what?
So two distinct indices. So let's take 1 and 2, right? So 1 and 2 is nums I is equal to nums j. No, it's not. Wait. Return true if there are two distinct indices I and j in the array such that nums I is equal to nums j, and abs I minus j is less than or equal to k. Two distinct indices. Is when it says two distinct indices, is that referring to I and j itself or the actual? Or does it mean that we must use two?
Oh, so I minus j, so like 2 indexes minus is smaller or equal than 3. So where's the false one? So where's 2 indexes that are minus that is less than 2? 1. I'll show you. Excuse me. If there are 2 distinct indices. So it can't be the same number.
I think it has to be the same.
I mean separate positions.
Yeah.
Wait, I
How
minus
does
j, that would just equal 0, would it not?
I'm just trying to think, how does this work with sliding window? You have a window, right? And then the window will slide across the input. So are you just like comparing like 1 and 2 in the first instance, and then you compare 2 and 3, and then 3 and 1?
Just chat to explain the hell. I'm asking chat, can you explain? And K is at most positions apart. Okay, I got it. 0, 1, 2, 3. So 1 and 1 are the same, and they are within 3 positions apart. So how does sliding window work? One, two.
So I guess the sliding window size would equal to 3, right?
Yeah, it'll equal
But
K, and we're just continuously moving until the end of the array. So yeah, that's easy. It's just a fixed sliding window, not dynamic. So we just need the basic sliding window algorithm, which I forgot.
I also forgot.
I'm on geeks for geeks. Int I equals 0, I is smaller than n minus k plus. What? Int current sum equals 0. Fixed. So sliding is I. Where's K from? K is the...
Now, if they aren't right, then if it's greater than equal to k,
Wait, is that how you create the last sliding window?
yeah. And then if it's greater than equal to k, that means we know that we need to shift the left pointer 1, else you do left plus plus. And then let's say they just aren't straight up equal to each other, right? So 1 and 2, obviously 1 and 2 is not equal to each other. That might be it.
Is it while P1 is smaller or P2 is... Oh, never mind. It's P2.
Let's just see if that works. What's the ABS function in Java?
Math.abs?
Oh, because we need to do this. Huh? So 1 and 2 is not good. Now check 1 and 3. It's not good.
Wait, why is right not at a fixed position of k?
Huh?
Why isn't right like initialized at position k? And then yeah.
Wait, so you check 1 and 2, right? And then you check 1 and 3.
Wait, why are you not checking like at k distance?
I am. So look,
So you're actually calculating it.
Because it's a window, right? So I start here, I check 1 and 2, right? Is 1 and 2 the same? No, it's not. So I remove right pointer 1. Now I check is 1 and 3 the same? No, it's not, right? And I move right pointer again, and I check is 1 and 1 the same? Yes, they are, right? And then if math ABS num left minus num right is less than or equal to k, then you return true. But mine returns true. It's something about loop. I think this is returning false. Anyway, we don't need that. We can do that plus plus. Close logically, but I think I'm messing something up with the indexes. We'll see ChatGPT. Oh wait, I think I need to actually compare the indexes. It's left minus right. It's not actually.
Dude, look at mine. Isn't it like basically this?
E1 plus K. No,
You're not,
I don't think
because
so.
you're only returning true when they're at a fixed distance of k. Oh wait,
Hold
no,
on.
it's less than. Oh, never mind. I thought it was. I forgot about
Correct
this.
winner plus hash set.
What?
Yeah, these are fucking hash set, nigga. Set integer window is equal to new hash set for in I is equal to none. If window dot contains nums I returns true.
What?
Okay, I'm gonna copy and paste this and we'll run through an example. Okay, so we'll just do this first example, right? So if window dot contains nums I it doesn't, right? So we'll just add it. So our current window is gonna have 1 in it. Now if window size is greater than 3, then actually let me just store something here. Right. So that's gonna be our current size. And window size limit is equal to 3. And our current window size, okay. So if we window.size is greater than k, so what, is it going to be 1 right now? So if window.size is greater than 3, it's not. So we just continue. And then if window.contains nums I, it doesn't, so we'll just add 2 as well. And our current size is 2. If window size is greater than 3, it's not. And then now we check if the window contains 3. The window doesn't contain 3, so we add 3. They're currently there. Now if window.size is greater than k, it's not greater than k. So continue. Now we add 1. So does 1 currently exist in the current window? Yes, it does. So we return true. But showing that.
Oh, because it's less than k, it doesn't run the window remove thing.
Because it doesn't add to the window. It only just checks if it contains it.
Wait, so why does it window.remove if it's bigger? So it just resets it? Or removes nums I minus k?
Let's try another example. Let's do this one here. So we'll just go ahead and add 1. And then we add 0 as well. But actually before we add it, okay, we add it. And then we see window size is greater than k, because we're currently at 2. So we remove nums I minus k. So that's going to be 1 minus nums I minus k. It's going to be 1 minus 1.
0.
So it's going to remove index. This one, I guess. Wait. How is this? You're removing from a hash set. You're providing the value. Oh, because you're providing the value of the first value in nums. So it's like remove 1. Okay. Now window size is back to 1. Now we add 1 in here. And now window size is 2. Now we do window.remove I. So we're at 2 minus k, which is 0 again. So it's always going to remove from the start. And then we add 1 again. Well, before we even add it, actually, we just check if the window contains 1. Then will instantly return true. So we're not even adding it. So the window size is 1, right? But we don't even add it. Interesting. I mean, I understand the logic. It's just, in practice, I'm getting a bit confused. But I've never seen using a window like this